So these are my outline. I'll be doing the introduction, talking about the principles of serum grouping, the materials needed, the general procedure, clinical significance, adopted advantage of serum grouping, conclusion, recommendation, and reference. Introduction. Just a preamble. Serum grouping is a type of one of the techniques in ABO blood grouping. So it's also known as reverse grouping, just like the normal one that we normally do here, cell grouping. In the BGS department, the serum blood grouping is something that we do often, just like in the house when you have a broom, we use the broom every day. That's how serum grouping is. But you know that when the broom is not there, every day becomes so messy. In case of blood grouping, when it's not gotten right, it could lead to fatal issues. So we have to discuss this next. In the course of this study, I'll be focusing on serum grouping. Serum grouping, also known as reverse grouping, is an ABO blood grouping method where serum is tested for anti-A and anti-B antibodies using known A and B red cells. Here, what we are trying to say is very simple. Instead of using cells like the red cells, we are now using serums to test for known A and to test against known A and B red cells. ABO blood group examination is a simple laboratory test performed to determine a person's blood group of 4 kinds. In the ABO blood grouping system, we have 4 major groupings. We have the A, the B, the AB, and the O. Next slide. So, in these blood grouping systems, we already know that in our A, we have antigen A and antibody B. In our B, we have antigen B and antibody B. In our group AB, we have no antibody, but we have antigen A and B. And in our O, we have no antigens, but antibody A and antibody B. Now, this is one of the things that makes the ABO blood grouping very stands out amongst other blood groupings. It is the only blood grouping procedure that has a reciprocal, like you can do the cell and the serum and you still get the same groupings. Next slide. Now, the principle of ABO blood grouping. The principle of ABO grouping can also be gotten from the procedure. Generally, BGS is all about antigen-antibody reactions, and hallucination shows positive reaction. But looking forward to what I have here, basic principle of ABO typing is that the forward grouping reaction, that's cell grouping, detects the antigen presence on the surface of the red blood cells of a patient when mixed with a known antiserum. And this should match the results of the reverse grouping reaction, that's the serum grouping, which detects the antibodies present in the patient's serum when mixed with standard red cells. Next slide. Now, the materials we will be needing for the test. We're needing a refrigerator, the refrigerator that stores the A and B cells that will be cooled to get our standard cells. The centrifuge for spinning. We'll be needing water baths. We'll be needing microscope, test tube rack. We'll be needing test tube rack, beaker, normal saline, 0.9 normal saline. It will be in the drop bottle. Then test tubes, pasture pipettes, lights, A and B red cells. Next slide. So these now generated images of some of the ones I used while preparing this. This is the centrifuge. This is the full A and B red cells, 20%. Then the drop bottle with normal saline in it. I use this as my beaker, the rack, the test tubes, and my standard A and B cells. Next slide. So the general procedure of cell grouping. I'll be doing this orally. The procedure is very simple. You get like 3 to 6 different known A cells. You bring them together. You add normal saline and spin until the spinactant runs clear. You make 20% suspension. 20% is 20 over 100. That's 1 in 5 division. You do it for A and also do it for B. Then when you've done that, you get your test tubes ready with your samples. You will spin the samples to separate the cells and the serum. Here we'll be using the serum. The samples are collected in a plain container. So you pick 2 drops of the patient's serum and put it in test tube A and B. Then for 20%, you use your pool cells. You add 1 drop for A. And if you pick the pooled cell for B, you add 1 drop in the test tube B. Then you agitate in the centrifuge. You incubate. First of all, you incubate for 1 hour in the water bath. Then you agitate in the centrifuge. And look for agglutination. In case you are not sure if you are seeing agglutination or not, then use light and check it under the microscope. Next slide. Okay, go back please. Okay, here. In this test results, In this test results, you will be looking at our controls. Before you start, in case you just prepared your O cell for the first time, you might need to have a known O cell or a known B cell that you will use as your serum. Reaction in O that you are very sure is O shows you that the procedure you prepared is correct. So it serves as O is a positive control, while AB is a negative control. So negative test results. Okay, go to the next slide. Let me talk about results here. So this is our result interpretation. Test serums plus pooled A. Okay, here if you're having reaction in the tubes with B, it shows that it is A because it's reverse. If you're having reactions in the tubes that is A, it shows it is B. And normally the AB, that's the control, will show you negative, will be negative, no reaction. Then in the O, you will see reaction. That's our positive control. Next slide. So this is the one we did. This one is showing a reaction. The other one is not showing a reaction after agitation. Positive agglutination in test tube A shows the sample is blood group. Next slide. So clinical significance of serum group. Transfusion reactions. This is one of the most important reasons why we do ABO blood group, to avoid transfusion reactions, especially transfusion reactions involving cold antibodies. Then hemolytic disease of newborn. This hemolytic disease of newborn is normally seen where we have a child with blood group O from a blood group A or blood group O mothers. If there is exchange of blood during birth from the placenta, the child must start reacting. Generally, I don't know if there is a cure, but the doctors know how to manage cases of hemolytic disease of newborn. Then blood products. So serum grouping is a nice grouping system because most of our blood group products don't have, apart from red cell concentrate, cryoprecipitate, fresh frozen plasma, poor platelet plasma, platelet-rich plasma, they don't have red cells. So if you know how to do serum group, it's a plus if you are not sure of their blood groups. Organ transplant and graft. So before you transplant any part of the body from one person to another, you must be sure that their blood grouping matches correctly. Next slide. Now, advantages of serum grouping. It can be used to settle cases of discrepancies with cell grouping. This is normally seen because normally we have cases of discrepancies in ABO blood grouping. Maybe when you are not sure after using your cell grouping procedures. So doing the serum grouping will help you to be able to be sure of the patient's cell group. It's normal, so it acts as a double check or means of confirming a cell grouping results. Normally, the WHO recommended procedure for blood ABO grouping is that you must do the serum grouping and the serum grouping. This will help you know if there's even any case of discrepancy in the first place. Apart from the one that we normally do, this person will get a different result, another person come and give a different result, then we use normal saline. Instead of doing that normal saline, this can also be a better and a more recommended procedure. It can be used to determine the blood group of a patient in the absence of antigen, provided there are no A and B cells. It is an alternative to cell group. Yes. Now, disadvantages of serum grouping. It is time consuming. It is very, very time consuming. Incubating for 1 hour is time consuming. Spinning till spinactans runs dry is time consuming. It is not cost effective. To the lab scientists, it is not cost effective because you use your normal saline. You have to provide fuel or generator or standby ways to protect the standard A and B cells in the refrigerator and many other things. It requires adequate technical know-how. Yes, it's not everybody that even knows that there's something like serum grouping and can do it. So it needs you to be skilled for you to be able to do it well. It can be difficult getting red cells since incoming blood grouping samples are few. Yes, because apart from the fact that we do donor screening in the same unit, in many hospitals, the donor screening unit is a different unit altogether. Getting standard A and B cells that you keep to use them regularly for serum grouping might be very difficult. Cells of free titer can give a false negative result. Next slide. Now, conclusion. Serum grouping is one of the 2 required phases in determining the ABO type of an individual. Next slide. Recommendations. It is best to use serum grouping for settling issues of ABO discrepancies. I've talked about that. Serum grouping be done at least once a month so that interns and students can learn the serum grouping in the lab if using it routinely is not obtainable. I'm recommending. proper care is taken while preparing the pool cells to avoid false agglutination, which can lead to false results. Always use pool cells to have high titer. Always make sure you are bringing at least 3 to 6, or at least 3. So that you make sure that your titers are high, so that weak antibodies in the serum will react. Next slide. So these are my references. Yes. I appreciate your time. Thank you.